So the fabrics are built around all TCP/IP, right? As long as I have TCP level connectivity with other node, doesn't matter WAN or non-WAN, the fabric protocol runs, right? The fabric is really a server cluster style fabric, right? It's a standard three-phase commit algorithm that runs, which is, can I take my state and distribute it to everyone? Can I take my configuration decisions and make sure across multiple distributed nodes, can I actually ensure that the configuration is synchronous, right, without causing problem? The few things, very big difference between scripting and how three-phase commit works, right? Scripting is, I'm going to go and do something on hundreds of switches. You're going to succeed in 10, you're going to fail in 10, or my math is wrong. If you do 10,000 switches, you're going to succeed in most of them except maybe 10. What do? The guys where you succeeded already got the new configuration. The guys you failed didn't get a new configuration. Whose problem is it to back out of that, right? You as a scripter now has to deal with all these error cases, failure cases, and what happens while you're backing out of that configuration, right? The database guys designed three-phase commit algorithm in 1984. It was a seminal SIGCOMM paper published in SIGCOMM in 1984, which is like, very simply goes like, I want to do a transaction. Are you guys ready? Here's my transaction. Can you do it? Right? Everyone replies to me, whoever is initiating the transaction, yes, I can do it. The transaction has not been committed yet. There's no change in configuration, but everyone is holding resources for it. If even a single guy says that I can't do it, your next step is fail, drop the resource reservation, right? If everyone says, 100% says, I can do it, your third phase is committed, right? And there is some stuff that goes on in between when you recover. How do you recover if things go crash in between, or one node said he's committed but couldn't really commit? When he comes back up, he looks at his transaction logs and says that I got to commit, and so on and so forth, right? A lot of people, the moment I describe this, think this is a very heavyweight operation, right? Let me describe you this operation, how simple it is. If you take a standard 2-socket server today, basically, right? It serves 100K to a million TCP session today. It doesn't have to be a specialized system. Go get the cheapest Supermicro box you can, dual socket, 64 gig memory and whatever it is. Run your favorite web server. How many sessions do you think that guy is serving? 100K without breaking a sweat, right? In this same scenario, from every switch to every switch, we do keep a one-to-one mapping. We do have a TCP session between each switch to other switch, right? I can have 100K session per switch. Yes, I can have 100K switch nodes without breaking a sweat. Yes, I do pay a little bit extra cost than pure switching sessions because all my fabric communication is SSL encrypted, right? So maybe it's not quite 100, maybe it's a little bit less, right? But on that TCP session, the only thing that's going on is, few packets saying, ready to do a transaction, few packets that say, here's the transaction, and few packets saying, I got it done, right? This entire operation in a data center typically takes some microseconds. Keep in mind, these switches are less than microsecond latency switches. You are max 2 hop away in a leaf spine model from other switch. We're not going through a lot of nodes to do this. Where does it start becoming a problem, right? It starts becoming a problem when your fabric is not just in one data center. When your fabric starts going multiple data center, right? Keep in mind, the fabric protocol doesn't care. The fabric protocol is still running. I got IP connectivity. I don't care whether other switches. There can be multiple devices in between. There can be Cisco's and Aristas in between. Don't care. As long as I've got IP level connectivity, I can run my fabric on that, right? But the latency of that transaction does matter. So today, if you're running multiple labs into the same campus, no sweat. You're running in the same metro networks, these fabric, no sweat, right? Where things starts to break down is, okay, I'm running a fabric between 2 cities. I got a data center here, a data center here, and I want to make sure they're in the same management domain, configuration domain, L2 domains, or L2 over L3 domain, basically. That's where we start to see issues, basically, right? And I'm going to dive into some of the things we're working on to fix those. But does this make sense? Now, coming down to the questions you guys were discussing earlier, where is L2 boundaries, where is L3 boundaries, and all those kind of things. it doesn't matter to us basically, because our fabrics are running independent of L2, L3, right? We've changed the world of networking that way. I'm not dependent on that L2, L3 to run my fabric. As long as you can give me IP level connectivity, don't care. It can be over L2 over L3, it can be a separate in-band network, it can be out-of-band network, don't care.
So let's use an example then.
Sure, let's go.
Use the example, we have 10 racks.
Yep.
And we want L3 in the top of every rack.
Sure.
Is that possible?
Absolutely possible.
L3 for a single segment. So if
I mean, distributed gateway type functionality.
Right. So is the default gateway hosted in every top rack device?
So you asked two questions, right? So let me answer your two questions one by one. L3 on each top of the rack, totally. Do you want to do that every time or not? What is our recommendation? Not probably at top of the rack. Our recommendation is still probably at the spine layer.
Why?
I'll go into that in a moment, basically, right? Then the second part that comes into question is that what is my routing configuration for my compute nodes, basically, right? They all point to a default gateway, right? Let's be very clear about this. What typically, I come from a world of server. I've seen a lot of server guys, they barely understand IP address, right? All they understand is maybe what is my other IP I need to talk. The moment you start saying what is the subnet mask, they already start getting confused, right? And they understand default gateway. They don't know any other thing. What's my default route? What is my IP address, basically, right? So now the question is, can you actually have virtualized route and capabilities where each rack is going to its top of the rack, basically, and getting default routed out of there? Absolutely.
Well, we're not looking for isolated to a rack, though. This is looking for an anycast VRRP.
You can have anycast VRRP, but keep in mind these configuration, there your routing configuration is getting complicated. If you take 12 rack, or how many rack did you say? 20?
10's fine.
10 is fine. 10 racks, each running its own virtual router at the top of the rack, each dealing with same routing tables and whatever, and same subnets, right? You are doing some configuration between at the L3 level between these routers, right? I'm not routing the router. I'm not writing the router. I'm allowing virtual routers to instantiate. I'm using Quagga, the same Quagga Google uses to create these routers. You still have to deal with that routing mess.
I think that's the issue, because you're looking at it from a process perspective. So, all right, we're running Quagga on these few boxes, but you can run them on 2 if you want, or maybe 30. But if you're running them on every box, it's just different, I guess, the way we think about layer 3, because we just think about L3 or L2 could be everywhere.
Yeah.
But here, saying if you want to instantiate that Quagga process on every top of rack, I'm saying, so are you beholden to what Quagga can do for you and for us?
Well, he has two questions. Like I said, Quagga is the best thing that's out there. We are beholden to Quagga. There be no mistake. We are not going down the path of writing our own L3 protocol.
I'm saying typically, sometimes the proprietary fabrics have things to do the shared gateway across racks. And again, I'm just trying to get answers out of you, so I do apologize.
We're looking for magic features.
You're looking for magic features. The magic is not in routing protocols. A lot of our magic is at the system level stuff, right? So to answer your question too is basically, right, the very interesting part is you can go ECMP and stuff like that, but the interesting part is if you actually configure the same routing table on all 10 top of the rack routers, basically, right, saying that here's my default route, just go to the nearest route, basically. We do mess with flows and stuff like that where we can make sure the rat actually goes to this individual virtual router underneath. It's not automagic today. You do have to configure free flows to override it. This is kind of how we do service chaining also. Again, no orchestration tools right now. It is vFlow driven, and you do have to type some vFlow commands to force this happen.
And that's how you'd have to do it, because the caveat with any distributed routing functionality is that how do you distribute that state? And what's tripping it in my mind is when I see things like built-in ARP suppression. You're already carrying the necessary information to do that because you're suppressing ARP at the top of rack, I assume. That's all you need. All you have to do is decrement the TTL at the top of rack. But then the question in my mind becomes, if you can do that, why would you prefer to have layer 3 done in the spine and implement the traditional, I call it traditional, but MLAG, to every top of rack? So in many ways that sort of limits, in my mind, the scalability of the fabric.
No, it is interesting enough, right? So let's go through a couple of things, basically, right? Why are we so excited about VXLAN, or tunneling in general, right? And you guys have been doing this for a while. You're talking to a lot of customers, basically, right? So let me start by asking, what is VXLAN bringing to the table?
Well, the questions for me, you can table that too for the group, but it was more coming, from almost every vendor out there is talking about L3 CMP fabrics.
Mm-hmm. Yes.
And like here, I'm almost sensing like the opposite. So that's where and that's overlays aside. That's just in general, sort of the ideal Pluribus fabric. What does that look like?
So the ideal fabric in our view typically, and maybe let me open another slide, which kind of gives you.
It's almost like if we go back 4 years, OpenFlow is emerging. It was almost every vendor would say, whatever you want to do is possible because we can do that and car flows going here and here. Mm-hmm. And that's like, it's a similar tone because it's so flexible, but it's still, what's the ideal architecture?
Yeah, where the best practice is for those.
Right.
Mm-hmm. Yeah, I don't care about VXLAN. To be honest, I don't care about encapsulation. I care about the fact that it's layer 3.
We are hearing a lot of people actually care about VXLAN without even understanding what it brings to the table. Mm-hmm. We are seeing a lot of customers. In fact, we have couple of customers who came in here saying that I went down the path, I did all these servers to service tunnel, and nothing against Pluribus. Pluribus is working fine, NetWise is working fine, but can you fix my server to server stuff, please? Right? So we have had guys who have, these are big companies with sharp guys who went into there saying that I was being sold this anyway, so I went down the path of bringing OpenStack in and trying to do this, and it's not working basically. Now L3 are also at the each rack level. Some people do it, some don't. And let me tell you what we are seeing basically, right? So we are seeing people going tunneling because the moment they bring L3 to the top of the rack, their VM migration domain is now restricted to the rack, right? They're trying to go to bigger pools. Right.
Well, this is why there's been a lack of L3 to the top rack, right, over the past couple,
Yes, you got it. This is why L2 is primarily at the rack level. So now my next question comes in with a lot of these guys, basically, then why would you not just go bigger L2, right? If L2 is serving your need, just go L2. We don't care. We support it. In fact, we make L2 run better than other L2s because, with built-in ARP suppression and multipathing and this and that and whatever, I can actually guarantee you to run L2 better. We have simplified the management so much. You need more bandwidth, just plug in 2 more wires between the 2 switches, any open port, walk away. We'll do trunking if necessary. We'll do multipathing if necessary. You don't have to worry about any of this, right? So why would you just not run L2? That's when it starts coming out. You go through this with 5 or 6, 7 customers, then it starts coming out. Why are they not doing it? Because a lot of them are, I got a lab here, I got a lab there, I got a lab across in the building other way. In between is a L3 network owned by corporate IT. I don't have control over this. Yeah. Right? And I need to make this all work as one. I don't want to deal with my separate pools as different resources. And then corollary to that is, I got my data center here, I got my data center there, and I want to make it work as one, basically, right? So it's not against L2. There were some problems with L2. Now, STP is broke, right? The moment people start using STP and whatever, they start, loops come in, it all melts down. They don't even know how it melts down, basically, right? So we've taken care of that problem. It's like, no, just because you connected 2 cables somewhere, you're not going to melt the network, basically, right? Feel free to move ports around. We have removed all port-specific configuration from our system, right? We understand what your MAC is. We know who you are. We can follow you. We have a control plane big enough to figure out, the guy unplugged a cable here, he plugged it there, or in a different switch. But what is plugged into that cable, I know what was plugged into that cable. I can figure that out, basically, right? So the real question is that, okay, I really want to keep my VM domain bigger, and I am physically separated. Some of my racks are physically separated, so I'm forced to go L3, right?